For number 44, just like number 42, we're going to be defining a function f of x piecewise that you can see graphed here. So the first thing we recognize is that there are two pieces, two domain restrictions, and so the first piece is defined over the interval from, or over the domain from x equals -1 to x equals 0. The second piece is defined, you can see that it starts at 0, but it goes with that arrow there. It means it goes on, continues forever to the right, which means for all x values that are greater than 0. And so defining the first piece, we recognize that it's a straight line, and straight lines have slopes. The slope is up 1, 2, and over 1. So the slope is 2. We can see that the y-intercept is equal also to 2. So the equation of that piece of the piecewise function, the equation of this line, is y equals slope, which is 2, times x, plus the y-intercept, 2. And so that piece is the one that we put right there that's defined between -1 and 0. Now the next piece is also a straight line. So straight lines, we immediately recognize that we need to find the slope being up 1 and over 1 from any point on the line to another point. To get there, we go up 1 and over 1. We know that slope is rise over run, so the slope of this line is 1. And then we can see that if it were to continue forever, it would have a y-intercept of 0. We realize that we can only have one y-intercept, but for the purposes of figuring out the equation of this piece of the piecewise function, we view the line as if it were going on forever. What would its y-intercept be? It would be 0. So therefore we can come up with an equation of this piece, and the equation is y equals slope times x, slope being 1, times x plus the y-intercept 0, so 1x plus 0, which is just y equals x. So the piecewise function then, the second piece, is just x when x is greater than 0, and that's it. That's the piecewise function definition.